Hello students, this is Miss Dalton and this video is over factoring patterns. The first pattern that we have is called the difference of squares, and you'll see this when you have binomials that are being subtracted, and so that's where the difference part comes in. If you see two terms that are being subtracted, and then the terms that are being subtracted, both of those are perfect squares. So what we mean by that is a number or variable that can be taken the square root of. So for example, you could have 25, right? Because we can take the square root of 25. The square root of 25 is equal to 5. We have 16, right? The square root of 16 is equal to 4. So these numbers right here are considered perfect squares. Now obviously if you have the variable a, or let's make it x. If you have the variable x squared, well obviously I can take the square root of something being squared, right? That's just going to be x. So again, you're going to be looking for variables that have an even power. If you have an even power, you can take the square root of them. Just like if we had x to the fourth, I can take the square root of x to the fourth. That's going to give you x squared. So you're going to be looking for variables that have even powers and numbers that are perfect squares. All right, so let's see how these are going to factor. So if we have this example right here, x squared minus 25. So one red flag is you'll see, oh, I've only got two terms. Well, then you need to look and see, are they being subtracted? Yes, they are. And are the terms perfect squares? And yes, they are. And so you'll go back to your pattern, which your pattern is, if you have a squared minus b squared, then how that factors is a plus b times a minus b. Okay, so look at how we're going to do this. So what you're going to do is you're going to take the square root of that first term, which is x, and you're going to take the square root of the last term, which is 5, and then these numbers right here represent your a and your b. So we just write our factors as x plus 5 and x minus 5. And if you multiply that back together, you'll see that that middle term does cancel out, which therefore has it become a binomial. Okay, the next pattern is what we call the perfect square trinomials. Now, sometimes these are hard to recognize that it is a perfect square trinomial. And so just remember, if you don't recognize that it's a pattern, it's okay. Still use factor by grouping or factor by box method. These patterns just give you a shortcut. Okay, so that if you recognize that it is a difference of squares or a perfect square trinomial, then you can use this shortcut. Okay, so we have this first one which says a squared plus 2ab plus b squared. How you're going to factor that is a plus b quantity squared, which is really just a plus b times a plus b. Now if you have a squared minus 2ab plus b squared, then you would factor that as a minus b quantity squared, which would be a minus b times a minus b. Okay, so what does this mean? Well, let's say I have, for my first term, let's say I have x squared, okay? And then let's say for my last term, I have 16. Okay, well then that means my a is x, and my b is whatever squared equals 16. So b in this case would be 4. Because 4 squared is equal to 16. So what we would do, what you would have in the middle is you would have plus 2 times a times b. So 2 times a would be that x, so 2x, and then times b, which would be 4, so you'd have 2 times 4, which is 8x. So that's what would be in the center. So this is what it would start out as. X squared plus 8x plus 16. If you recognize that, and something that I do to always recognize that this is a perfect square trinomial, is I will take the square root of 16, which gives you 4, and then double it, 8, And if you have that as your coefficient here, then it could possibly be a perfect square trinomial. Okay, so then how this factors now is I would take my a, which again was x, plus I would take my b, which was that 4, and quantity squared. Okay, so let's look at another example. So we have x squared plus 18x plus 81. So again, if you don't recognize that this is a perfect square trinomial, you could still factor by grouping and factor the box. These patterns just give you a faster way to factor. So at this point, what I would do is I'd say, okay, this looks like I might want to go ahead and check it to see if it's a perfect square trinomial. So how do I do that? Well, what squared gives you x squared? X does. What squared gives you 81? 9. Okay? Well, x times 9 is 9x. And then if I double it, so times 2, if I double that now, it does in fact equal that 18x. And so therefore I know that this is a perfect square trinomial. So now all I have to do is take this and use the sign that's right there, and there are my factors, x plus 9 quantity squared. Okay, let's look at a little more complicated problem. So one thing I would do is anytime you have an a that's not 1, I always try and look and see if I have a GCF. So is there something that I can divide out of 4x squared, 20x, and 25? I can't divide them all by 4, so I would stop there. Okay, well, I do recognize that the n terms, 4x squared and 25, are perfect squares. So this might be a perfect square trinomial. So think about what squared gives you 4x squared. Well, 2x does. 2x squared gives me 4x squared. Okay, well, what squared gives you 25? 5. 5 squared equals 25. So now, take these two terms, 2x times 5, that gives you 10x, and then double that, and that does, in fact, equal that 20x. So therefore, this is a perfect square trinomial. I'm going to take my numbers here and here, my numbers and variables, and I'm going to use this sign that's right here. And so now it's going to be 2x minus 5 quantity squared. And just to show you that this does in fact work, let's take 2x minus 5 squared, so write it down again, and let's just show that when I multiply this together, it does in fact give me that original problem. So I'm going to take 2x times 2x, that gives you 4x squared. Then I'm going to take 2x times a negative 5, which gives you negative 10x. Then I'm going to take negative 5 times 2x, which gives you negative 10x. Then I'm going to take negative 5 times negative 5, which gives you that positive 25. Oops, it changed colors on me. Okay, so positive 25. Okay, well, when I add that up, my like terms, 4x squared, I add up my like terms, that would be a minus 20x, and that would give me plus 25. So you can see that this matches what the original was. Okay, so again, these factor patterns are not necessarily something that you have to use, but it does give you a shortcut if you will recognize that that's what these are. All right, make sure your notes are filled out. Come to class ready to learn.